As soon as some students see questions like this with powers, radicals, and fractions, they just freeze. Today, I'm going to be sharing with you one simple trick for you to solve questions like this so that that student will not be you. Let's start with the first one. Here, I have x to the power of 4 minus 5x squared plus 4 equal to 0. If you look closely, this is x squared. X to the power of 4 is actually x squared squared. So that means I can replace x squared with another letter. Let's say t will be x squared. So instead of writing x squared, I'm going to write t here. So this will be t. Then this will be squared. Then minus 5. Instead of x squared, it will be t plus 4 equal to 0. Very simple trick. I identify the repeating variable, then replace it with a letter. Now you have a simple quadratic here. To solve this quadratic very simply, we'll just do something like this. So what can I multiply to give me the constant? And what can I add that will give me the coefficient of t, which is minus 5 in this case? So what two numbers can do that? We can use 4 and 1. 4 times 1 gives you 4. But 4 plus 1 doesn't add up to minus 4. So let's put minus signs here. Minus 4 times minus 1 gives you plus 4. And minus 4 plus minus 1 gives you minus 5. These are the numbers we need. So we have t, I'm going to do t minus 4, then t minus 1 equal to 0. So this just simplifies into this since I've found both of this. So t minus 4 is 0, meaning that t is 4. And t minus 1 is 0, meaning that t is 1. Now don't forget, you said that t is x squared here. So it means that x squared is whatever t is, which is 4. So here you find the root of both sides. X equals to the square root of 4. X will be 2. Again, x squared is 1. So x will be the square root of 1. The square root of 1 is 1. Therefore, your values for x are 1 and 2. Very simple. We solve this easily. Now let's do the second question. For this second question, to solve it, we still have to substitute. So we need to identify what is repeating here. So I have root x and I have root x. Since I can see that root x is repeating, I'm going to substitute it. That's the whole idea of our substitution trick. So I'm going to say, let u be equals to root x. So wherever I see root x, I'm going to put u there. Then this is 2. So here I have a fraction. Whenever you have a fraction, multiply by the LCM. The LCM here is this number, or this letter rather. So multiply by u. So you will have u times u plus u times 1 over u equals to u times 2. U times u is u squared. Then u will cancel u. Then you have 2u. All right, let's arrange it better. So u squared minus 2u plus 1 equals to 0. Now it's time to factorize this. We're going to look for two numbers. We're going to look for two numbers that will multiply to give us 1. And we'll add to give us minus 2. Okay, so those numbers, the only thing you can multiply to give you 1. Integers will be 1 and 1. To add them, we have to put minus signs here. So minus 1 gives us minus 2. What that means is that u minus 1 and u minus 1 is 0. So u minus 1 is 0. So u is equals to 1 twice, because this is also giving u equals to 1. So since your u is equals to 1, and you remember that root x is equals to u, so root x is equals to anything that u is equal to, which in this case is 1. So root x is equal to 1. So x will be equal to the square of 1, which will still be 1. So x is equals to 1 twice. That's the answer to your question. Let's do the third one. For our third one, we have a nested problem. And it's still similar, but we need to identify the bad guy. The bad guy in this question is this one. This is the bad guy. So we're going to substitute it using, let's use f. So f equals to the root of x plus 1. So we'll square both sides here. So when I square, this will be f squared. The square is going to get rid of the square root. So you have x plus 1. Okay, I'm not done. We'll now make x the subject of the formula here. So let's f squared minus 1 equals to x. So f squared minus 1 is x. So wherever I have x, I'm going to write this there. So instead of x, I'll write f squared minus 1 minus 5. That's this 5. Then square root of x plus 1. Square root of x plus 1 is f. So I'm going to put f there. Plus 5 equals to 0. Let's sort this out. Minus 1 plus 5. So f squared minus 5x. Then minus 1 plus 5 is plus 4 equals to 0. So here again, I have a simple quadratic. But for this, I had to do a little longer to establish our substitution. So now we have this. We solve this the same way we'll be solving other ones. So my dash times dash gives us 4. Then dash plus dash gives us what? Minus 5. So what do we multiply to give us 4? We're going to go with 4 and 1 again. Then can we add 4 plus 1 to give us minus 5? No. So let's put minus here. So that's minus 4 minus 1. So we're going to have f minus 4. F minus 1 equals to 0. So f minus 4 is 0. F equals to 4. And f minus 1 is 0. So there's no confusion. F equals to 1. So we found f. I have to remember that f is equals to root x plus 1. So whatever f is, root x plus 1 is that thing. So root x plus 1 is 4. To get rid of the square root, to square both sides. So this will be x plus 1 equals to the square of 4, which is 16. So x equals to 16 minus 1. X is 15. Then again, root x plus 1 is equal to 1. Get rid of the square root, that'll be x plus 1 equals to 1 squared, which is 1. And x equals to 1 minus 1, and x equals to 0. So we have our values for x again. So it's pretty simple. Figure out what is repeating, substitute it, then solve. Okay? Catch you in the next video.